Hello guys, welcome to chemistry class again. Good morning, good afternoon, good evening. In our previous videos, we have been discussing alkanols. Today we want to talk about the chemical properties of alkanols or the reactions, how alkanols react. That is what we'll be talking about. And if you look at the board, we have some of the reactions of alkanols. Remember, this is the general formula of alkanols. And you can see the functional group OH with two lone pairs of electrons around oxygen. So number one reaction is acid dehydrative elimination to form alkenes. What this means is that alkanols, in the presence of an acid, an alkanol undergoes an elimination reaction in the presence of an acid to form an alkene. 2. Combustion reaction, where alkanol bonds in oxygen to produce carbon dioxide and water. 3 is reaction with a metal to yield alkoxide. 4. Reaction with HX, that is hydrogen halide compound, to yield an alkyl halide. Halides are formed from halogen elements. 5. Esterification reaction. 6. Oxidation to aldehyde, ketones, and alkanoic acids. So let us now look at number 1. Acid dehydrative elimination to form an alkene. That is number 1. Or you can call it dehydration. Dehydration of alkanol to yield an alkene. And of course, and water. Dehydration means elimination of water from a substance. The general summative reaction of this, let's take for instance, example, reaction of ethanol to yield ethene in the presence of H2SO4. So look at how it is. CH3, CH2, OH. This is an ethanol. This is ethanol. Now, in the presence of this acid, H2SO4, ethanol becomes ethene, CH2, with elimination of one molecule of water. That is just the overall reaction. But let us now look at the mechanism of the reaction. Mechanism. By mechanism, I mean the step-by-step of what actually happens in the formation of ethene. Now, we have step 1. Step 1 is protonation by the acid. Protonation, where this is the ethanol. This is the ethanol. Now, the acid will protonate, produce a proton, H+. And what happens here is this. This proton produced by the acid will be attracted with the highly electronegative oxygen. Because it has lone pair of electrons, the lone pairs of electrons move into the proton to establish an oxonium compound. Oxonium compound is a compound that contains oxygen with 3 bonds and one positive formal charge. So this is the compound that will be produced. You repeat CH3, CH2, and the O, H, and plus. Remember, a lone pair of electrons moved out, and hydrogen got bonded to oxygen. And because a lone pair of electrons moved out, we have oxygen that is now positively charged. So this compound is called ethyl. From here to here is ethyl. Ethyl oxonium ion. That is step 1. So step 1 is where the acid protonates the ethanol to form ethyl oxonium ion. Now step 2. Step 2 is the slowest step, and it is the rate determining step. Because this step is where there is formation of an intermediate known as carbocation intermediate. And what happens there is this. Where this ethyl oxonium ion now reacts, and let's see the reaction. What happens here is that the oxygen in this ethyl oxonium ion is even more electronegative. So what happens is that it will break this bond. There are two oxygen atom bond pairs here. It will take the bond pair, and this bond is broken. If this bond is broken, it means water is eliminated. You can say minus water. And we have a carbocation intermediate. Because the bond broke and the pairs of electron in the bond got lost from carbon, carbon became positive. And that is why it is called carbocation intermediate. This is carbocation intermediate. Plus water. Now, water is eliminated. Remember, water is H2O. It got eliminated. Now, this carbocation intermediate is highly stable. It's highly stable. That is why this reaction is possible. When the product is more stable than the reactant, the reaction becomes feasible and even spontaneous. So this is a self-reaction. Now, the next step, step 3, is where there is deprotonation. This carbocation intermediate will deprotonate to form ethene. It's called deprotonation. Deprotonation reaction. And look at what happens. Look at what happens. Because this particular carbon is more electron deficient, this bond here will break into the carbon. We take the available electron into the carbon, and what we have is, look at what actually happens. The bond breaks into this particular bond, so that carbon will no longer be positive, but a double bond is established here. So we now have CH2 double bond, CH2 with H plus. That is why the reaction is called deprotonation, removal of proton. Now this proton will now be attracted by, remember, acid lost proton at the beginning of the reaction. The proton will reunite with the hydrogen sulfate ion of the acid to reproduce the acid H2SO4. Once this acid is reproduced, and this by the process in which the proton is lost, the equilibrium will now shift to the right, and we now have more formation of ethene. And this is the end of the reaction, where ethene is produced from ethanol.